Okay. I think we're in business. Okay, let me just get my counter again. Okay. All right, so this one says, a golfer hits a ball from the ground at a 20-degree angle to the horizontal with an initial velocity of 132 feet per second. We have to model the motion of the ball with a set of parametric equations for the horizontal and vertical distances that the ball is from the golfer after t seconds. Okay, then we're going to give the location of the ball after a couple seconds, and then find out how far the ball is from the golfer when it hits the ground. Okay, so we got a bunch of stuff going on in this one, and notice this one is a calculator allowed, for sure. Okay, so first thing I want to do is A, which is model the formulas. And these are formulas that are given on your formula sheet. One of them starts with x equals, and one of them starts with y equals. And that's very similar to the examples that we just did in the number 31 and 32. One starts with x, one starts with y. Okay, so my initial velocity is 132. And that's going to be multiplied by the cosine of the angle, which is a 20-degree angle, over time. And then the y equals 1, the horizontal one, is negative 16t squared plus, and then we're going to do the same thing that we just wrote here, but with sine. 132 sine 20t. And then the initial height, the original height, which a golf ball would be 0. So it's up to you if you want to write the original height. It doesn't really matter. It's not going to make a difference either way. A lot of students ask where the negative 16 comes from. This is the number that accounts for the gravity factor, right? We know if we throw something up in the air, it comes back down. And so that's the number in feet per second that's used to account for gravity. Okay, and I think we have just done A. All right, so for B, it says locate the ball after 2 seconds. Okay, so there's a couple of ways you can do that. One way you can do that is plugging in t, plugging in 2, anywhere you see a t. So I could evaluate it 2 right here, and right here, and, just do it on the home screen of your calculator. Okay, that will totally work. Another way that you can do it is to put your calculators in degree mode, and parametric mode. So I'm actually already in degree mode. Let me just go down to parametric mode. Okay, and now when I hit y equals, there's my x equals and my y equals. So 132 cosine 20, close that 20, and then x. And then negative 16 x squared plus 132 sine, make sure you're using sine this time, x, and then plus 0 if you want to. I mean, you don't have to put it in there. It's certainly fine if you do. But now if I want to know how high is the ball after 2 seconds, or I'm sorry, the location of the ball in 2 seconds, let me go to my table. And I can find that in 2 seconds, the answer for x is my horizontal distance, and the answer for y in the y column is my vertical distance. So 248.08. Let me write down the numbers, and then we can talk about what they are. 26.293. Okay, these are both in feet. Okay, but this guy right here is the horizontal distance. And this one is my vertical. Okay, so what that means is we hit a golf ball at a 20-degree angle from the ground, if the initial velocity 132 feet per second, and in 2 seconds, the ball has gone 248 feet horizontally, so away from you, and has gone 26, and at that point, it's 26.293 feet high. Okay? Oop, 3 decimal places. I think I need to put 1 more decimal place on my horizontal, sorry. Looking down at the bottom, I see it's 079, actually. Sorry, so I should change that to 079. Okay, and then C. How far is the ball from the golfer when it hits the ground? Right, so, and give your answer 3 decimal places after. So what I want to know is if it hits the ground, you agree that the y, the height, has to be 0. right? I want to know when the ball's actually on the ground. So it doesn't ask me to make a graph, so I don't really need to worry about the graph too much. But if you look at the table here, do you see how the y coordinate, right, which is my height, I know that it hits the ground between 2 and 3 seconds, right? I know it hits the ball within the ground within 2 and 3 seconds. So if I just hit graph for a second, and I probably do not have a very good window on this. Yeah, and you can see that if I just hit graph, you know, this is pretty terrible. I mean, I'm only seeing the ball just getting hit. Remember, keep in mind that at 2 seconds it was 248 feet, and my standard screen's probably going to 10, you know? So let me go ahead and mess with my window a little bit. Okay, I have from 0, my T min to max. Keep that at 0 to 10. We know it hits the ground between 2 and 3 seconds, so going to 10 seconds will be totally fine. Keep your T step at 0.1. That's a good kind of standard. Okay, but X min, so this is, you know, -10, or we can say from 0. Now again, we knew that it went 248 feet in 2 seconds, so I want to go even bigger than that. Maybe we'll say like 300 feet or 350 feet. You know, I don't know, I'm just gonna kind of pick something big. The scale, you can count by 1, you can change it to count by 10, it doesn't really matter, it just depends on how many tick marks you want. Now the heights, -10 or 0 is fine. And we want to go, well, let's see, I know this was 26 feet. We actually don't really care very much about it doesn't ask me for the maximum height. It's just asking me when it hits the ground. So this doesn't really matter too much, but I might want to make it a little bit higher just in case you want to get a picture of, you know, what is going on with this. Let me go ahead and hit graph, and I might need to adjust this still a little bit. Oh, and it actually looks pretty good. I see just about everything that I need, and this right here is really what I'm interested in, right? I want to know when it hits the ground. So let me go ahead and hit the trace button. Okay, so time 0, I've gone horizontally 0, it's in the it's 0 in the air, and I'm just going to move along. I'm hitting my over arrow key, and here I'm going 5 seconds, 7, 8, and there was my 2 seconds. Let me go back, right? Remember, these numbers are just redundant. And again, I knew it was between 2 and 3 seconds that I hit the ground. And what I'm going to do is just try to see if I can find the closest that I can. This says, I think that's how it is. Yeah, if I go back. So in 2.8 seconds, it's 0.97 feet off the ground. So it's like almost 1 foot off the ground still. So the closest time I could find was 2.8 seconds. So what I want to do is I'm going to get a little slick here, because this says I have to be 3 places to the decimal point. So what I'm going to do is I'm going to hit second and window, and I'm going to have my table start counting at 2.8 seconds. And what I want my table to count by is 0.01, because then that'll give me to the nearest, I'm going to get my time to the nearest 100. Okay, so let's go to the table now. And now I'm starting at 2.8 seconds. And it looks like the closest to the ground, right, is 0.07 right here, so 2.82 seconds. And what is the location at that time? And this one we have to say to 3 decimal places. So 349, and I'm going to get it on the bottom because I need 3 places. 349,791. Okay, so it's on the ground in 2.82 seconds when it is 349.791 feet from the gopher. Okay. Here's one more. A punter kicks a football from an initial height of 2 feet with an initial velocity, my timers, of 82 feet per second and an angle of 63 degrees with the horizontal. Okay, so let me go ahead and write equations for this one. Okay, so my x equals will be the initial velocity cosine angle t. Negative 16t squared. Same thing but with sine. And then this one had an initial height of 2 feet. Okay, I want to know the position of the ball at 1.5 seconds. Okay, so let's go ahead to our y equals, and let's replace my equations. Oh, you know what, I should just start from there. So for it to use sine, okay, and I want to know in 1.5 seconds. So let me go ahead to my table settings. I'm sorry, second table set. And let's go put in 1.5. Right? I want my table to start at 1.5. And now when I go to the table start, here's my info. So 55.841, and that's the horizontal distance. And vertically, it's been 75.594. 55.841. And then the y equals, I'm going to leave myself some space so I can fill in some words, 75.594. I think I wrote that right. Okay. So this is feet vertically, and this is feet horizontal. Right? So the x is how far it's gone from the football, from the punter, and the y is the height. Okay, a player is standing 6 feet tall. A player is 6 feet tall, standing 50 yards from the punter directly under the path of the kick. Will the ball go over his head? Okay, so what we need to know, and this is all in feet. Okay, I want to know when x is 150, right? Because we're talking about feet. So I want to know when x is 150, what is the t? So we want to know like how high it is at that time. So let's go check something out here. So at 150 feet, so we might want to, let me take a peek at the graph here. Now remember, this is the window from the last problem, and actually it's fine. I mean, I can see everything I need, which is good. So I'm going to go ahead and hit trace, and I'm going to keep an eye on the x, right? I want to keep an eye on the x. I want to see when I get kind of close to 150 feet. So I'm going to kind of scroll, and I'm going to try to get close to 150 feet. That's pretty close. Let me go back one. Okay, so at time equals 4, let's just see where we're at right now. At 4 seconds, right, it's 148.9, which I know isn't quite 150. But look how high the ball is. Look at the y-coordinate. It's 38 feet in the air. Even if I go a little bit further, even if I go to 4.1 seconds, which is 152, which is a little bit further than we were supposed to be, it's still 32 feet in the air. Do you see that? So that's going to definitely go over the guy's head. So the ball is approximately, 32 feet high. So that is going over that dude's head. Okay, and then last one. Suppose that a ball hits the ground. I want to know when will the ball hit the ground and how far from the punter will the ball be, and give both of those to 3 decimal places. Okay, so let me go ahead and keep tracing, because now I want to know when it's going to hit the ground. So that was pretty close. Okay, this is 6.7 feet in the air, and then this is -4. I'm just going to go to the one above, and we're going to go hunt for the answer in our table. So 4.5 seconds. So I'm going to hit second window, and I think it was 4.5 if I haven't forgotten already. I still have my table settings to 0.01. So our time, we're going to go keep an eye on the y coordinates here, and I want to find the closest I can to 0. and it looks like it's right here, right? 0.26 is closer than negative 0.4. Doesn't matter if it's positive or negative, we're just finding the closest one. So this is when it's at the ground. Okay, so it's traveled 170, we have to get that to the 100th, 0.873 feet. Okay, and then my time will be 0.459 seconds. So this will be 4.59 seconds. So we'll say in time the ball is how many feet from the punter? 170 point. And I remember we had our get the hundredths place, so 873 feet from punter. Right? So basically he kicked it 170.873 feet. Okay, I'm going to stop this one.